Right, so you already should have the note, maybe not on you. Just coming from page 92 in your notes. 8.10. They're not the ones I've just given you. Okay, so in our extension linear functions we found the angle between two lines. Okay, so we're doing the same thing, except we're now finding the angle between two curves. We're using the same formula. We just need to do some calculus work first. Okay, so to calculate the angle between two curves, we simply calculate the gradients of the tangent to the curves and then use the formula that was already covered in extension linear function. Okay, so the acute angle, theta, is given by a tan of theta, the absolute value of m1 plus m2 over 1.
It's M1 minus M2.
Thank you. Good to see that you're remembering stuff. Or you've got that in front of you. Alright, so use the same formula, same principle when we're finding the angle between two lines, but you have to find the gradient of the tangent at that particular point. Okay? So example, find correct to the nearest degree the acute angle formed at the intersection of the curves y equals x squared plus 3x and y equals 4 on x. Okay, so there's two curves that will intersect at a point, because you're told about the intersection of the curves, and we need to find correct to the nearest degree the angle formed. Okay, so a couple of things we need to do. We find the intersection point. Okay, now we only actually need the x value of the intersection point, because we only need the x value to calculate into for the equation of the tangent when we calculate the first derivative. Sorry, the gradient of the tangent when we calculate the first derivative. I might find the intersection first. Equation 1, equation 2. Both are y equals, so put 1 into 2. So 4 on x is x squared plus 3x. Right, what's my next step?
Solve this.
Yep, and what's my next step to do that? Good. Remove the denominator. One of the first things you should be looking for doing when you solve your equation.
What?
Morning.
It's got my morning thing up. I'll be good. Probably that's just as I was sleeping. Like,
Oh, that a big mess.
it's splattered everywhere and it's so into the carpet.
What was it?
Probably good.
Nice. Alright, so x cubed plus 3x, take away 4 is 0. This is a particularly interesting question. So what's your suggestion, what to do next?
Backwards.
Yep, how?
By the column factorization.
Very good. Alright, so we're revising our polynomials work. So Robin, we are finding the angle between two curves. We use the same formula as we've done with angle between two lines. Okay, but we need to incorporate calculus skills. Find the gradient of the tangent at those 2 points, and that will be your 2 lines for this formula. Okay. The other thing you will also need to do is find the intersection point so that we can write down the gradient of the tangent for each respective curve. Okay, so we've got a factorise now because we need solutions for x. So we've got a cubic out the front. 3 terms, it's not so straightforward how to factorise that. Okay, but we need to go back to our polynomials work. So, call it p of x, and what p of x equals 0. So remember, factors of the constant terms, if it equals 0, okay, will also be a factor of the whole polynomial. One plus 3, 4, take away 4, 0. Take away 1 is a factor. So remember your final exam is everything in your prelim course, okay, including way back when we did polynomials.
Would that be x squared?
Sorry?
When you first wrote p of x equals x?
Yes. Good, thank you. Not that it makes a difference from that answer. Okay, so we need to remember to put each decreasing power of x in there, including coefficient of 0. I've picked up that, I forgot to put the square here. Yep.
And why is it 0x squared?
So,
So why is it 0x squared and not 3x squared?
because that should be a 3, and that should be a 0. Sorry. Something's wrong. Should get a main of 0, shouldn't I? Why put that there? I don't know. Better. The best of us makes careless mistakes at times. that one should not be an intersection. Why do we get two intersection points? Bear with me for one moment. Because I know the graph should only have one intersection point. Not my morning, this morning. That will be 1, and that point there will be -2. It literally touches at one point. Find the correct nearest degree, the acute angle formed at the intersection of those two curves.
Which one?
Well, either intersection can have an acute or an obtuse, isn't it?
Yeah, there's more than one intersection.
Yeah. I looked at these notes yesterday and I'm thinking, oh yeah, there should be no problem with that come lesson. I usually do all the examples the day before or the 2 days before. Now it's coming back to bite me. Well, some good to come out of this if we did practice our long division. Alright, let's try. Alright, not going to fiddle around anymore. Let's do that intersection there. Okay, so there should be only, you should be told what intersection it is if there's more than one, or there should only be one intersection point. Okay, so that was my bad there, but like I said, we did have a quick look at long division. Okay, so which can be accessible. Right, so let's take this point here, okay? So, if they were told that, I would actually could technically stop here, couldn't I? Okay, because that will be my solution for the equation. one solution for the equation if I'm given enough information to know that. Okay, so let's take right. So the question will be clear in terms of there's only one intersection point or which intersection point I want you to use. Okay, that was my fallback there. Right, so let's take the intersection at x equals 1. Right, so we found the x value where the two curves intersect. Okay? Okay, so we need to use this formula here. So we've found the intersection point x. We don't need to find the y value because we're just finding the gradient of those two tangents. Okay, so we now need to incorporate our calculus skill. So y x squared plus 3x, so y dash is 2x plus 3. Now x equals 1, y dash is 2 plus 3, which is 5. Okay, and that can be your M1. Y equals 4 on x, which is 4. How do we rewrite that so I can differentiate?
4 times x minus 1.
Okay, or you can use your quotient rule. Okay, you could use your quotient rule. Okay, so now we've got our two gradient. Yep. Right, so now we can use the formula. So tan theta is the absolute value of M1 take away M2 over 1 plus M1. I wrote M1 plus M2, start. And Michaela quickly perked up and said, oh, it's M1 plus M2. I said, oh, very good, I'm glad you remembered it. And then it turns out she got it right in front of me. Okay, so equals 5 take away a negative 4 over 1 plus 5 times negative 4. So it's going to be absolute value of 9, 5 negative 20 plus 1 negative 19. So theta is going to be tan inverse of 9 over 19. And we want that correct to the nearest degree. So,
25.
25. Okay, so there's nothing really new. Alright, it's just incorporating your mathematics calculus into your extension angle between two lines. Okay? Any question? Alright, second one. Find correct to the nearest degree. Find to the correct to the nearest degree the obtuse angle formed by all points of intersection of y equals x squared and y is negative 2x plus 3. Okay, the sketch will be handy. And negative 2x plus 3. Right, so there's going to be an intersection point here somewhere, and then way up here, there's going to be another one there. 1 and -3 are your two x values of the intersection. Okay, so again, you're not asked to find the intersection point. You're only finding the x value, because we need to substitute that into our first derivative of both those curves. Okay, not requiring to find the intersection point. Alright, so one benefit of labelling an equation, okay, I can go straight to there, which I probably should have done over there. So from equation 1, y dash is 2x. I'm going to rewrite things a bit differently. Alright, so at x equals to 1 first, y dash is going to be 2, so m1 is 2. So I'm going to go m1, m2, and then I'm also going to go m3, m4 for your second point of intersection, and just incorporate that into a second formula. Okay? Alright, number 2, y dash, well, at x equals -3, y dash is going to be -6, so m3 is -6, not m2, m3. Okay, so y dash is going to be -2. That means your m2 and m4 is going to be the same number. And of course, we're expecting that because we have a straight line. Alright. So m2 is -2 and m4 is also -2. So at x equals 1, tan theta is the absolute value of m1 plus m2 all over 1. No, take away. Plus m1, m2. The absolute value of 2, take away a -2 over 1 plus 2 times -2. So we need the obtuse angle. So we need to remember our extra step. -4 plus 1, -3. Okay, so our obtuse angle theta is going to be 180, take away 10 inverse of 4 over 3. Okay, so we don't round into our final answer. To the nearest degree. One, two, 7. Do you agree? Yep. Okay. The other intersection point, x is -3. So at x equals -3, so tan theta is the absolute value of m3, take away m4, over 1 plus m3, m4. 127 degrees, don't get units. Right, so the absolute value of -6, take away a -2, 1 plus -6 times -2. So you have the absolute value of -4 over 13. So for obtuse angle, use 180, take away tan inverse of the acute angle.
It's
Is it? Shouldn't be. Is it? Yeah. Interesting.
I know it's not me, but me, you're wrong thing.
It's wrong. You agreed, so you're wrong too.
No. Have you looked at the calculator? Have you done it on? Have you done it
Oh,
on?
there's a 1 there.
I would not expect them to
I
do the
didn't
same
see
answer.
a 1.
Hey?
No, I'll put it on. I'll put it on for me.
Well, give me the correct answer, you said. 160. Did either of you look at that and go, really, they're the same answer? Did any of you even comprehend that?
They're the same. I'm like, okay, 4 and 3. Yep.
Well,
They're the same.
that's the danger in not.
I didn't look at the one.
Oh, you didn't see this one here.
Yeah.
Right, yeah. Okay, so we'll to it. Okay, so you might get some thinking style questions in your exercise, but that's the basics. We'll get you going in the exercise. Any questions on intro to calculus section? That's it, okay?
That's it.
That's it. For your prelim course.
I was also scared of.
I was liking that.
Hey,
What are we doing next?
we're doing data and function graphs.
Good boy.
Which is essentially harder graphing, okay? Now you should already have this, but for today's lesson, I'll give you a copy. They should now have all your extension notes.
Oh,
Should.
I can make the booklet now.
Theoretically, yes. And should have everything but your quadratic functions for mathematics as well. Alright. So there's a lot more calculus involved in your HSC course and all your courses. Okay, so that's why it's called intro. You're just getting the skills. Some application, but further applications will occur as you go through the course. Okay. Where are we? We are on page 85. Alright, 5.11. Okay, so we've already talked about limits when we're differentiated using first principles, and we're coming up to it in functions and graphs in mathematics. Okay, so we're showing you something that we haven't done the basics for yet. Okay, but you have seen it in mathematics in terms of differentiation by first principle. Okay, hopefully we get some understanding, and then when we do it in mathematics, it'll hopefully get more clearer. Okay, here is the special limit. Limit as x approaches infinity, for in other words, a very large x value, okay, of 1 over x, okay, is equal to 0. So in other words, you put in your calculator 1 divided by one very, very large number, okay, you'll have your answer that is very close to 0. Okay. Are you familiar with your hyperbolas?
Yeah. Well,
Okay. So y is 1 on x. Okay, so we're about to cover this in mathematics and functions and graph. Essentially, it's this. That. Alright, so what this means, when we have a very large x value, okay, so here's your x-axis, when you take a very large x value, okay, the curve itself, or your y value, will get very, very close, but not get to 0. Okay, that's the idea of a limit. Alright, so what happens when you substitute a very large number in the positive direction, or a very large number in the negative direction, will also approach 0. Okay, That's the concepts of limits. Limits are, when we're evaluating limits, it's one of the more useful ways in to help with the aiding of sketching harder curves. Curves that are not straightforward like this, okay? Curves that have a lot more detail than what we're looking at in mathematics, okay? So, when we divide all the terms by the highest power of x, okay, and I'll explain that, this will become clearer in your example, will allow us to incorporate that rule. So, example, for the limit as x approaches infinity of 5x squared all over x squared take away 3x plus 2. So, in the next couple of lessons, we will be graphing that. Okay, we will be graphing that function. Okay, we've got to get the skills done first. So, if we were, actually I'll get it loaded in a moment. I'll do it now. I want to project it, but I don't. Oh well. I'll be back. Morning.
Taking physics, so Asian lady walked it up. Yeah, is she the one taking us to physics? You know? No.
Taking physics, what do you mean?
Hub's going on 2 weeks holiday. Yeah. And we're getting 16 for 2 weeks.
What do you mean?
Fix. Walked it up into physics.
What do you mean?
Fix.
7.
And we'll take time to read it. So yeah.
Triangle. Triangle. Yeah. Oh, sorry. One page. Okay. I'll put it on. I'll put it on for now.
160.
Yeah.
Okay. Yeah, what a creation. Chemistry, physics.